Now, it's important to note in that last question that there are other symmetries involved in here, but we want to choose the easiest ones that we can work with. So there are other symmetries. So if I drew a line through here, we can see that it is actually symmetrical across pi over 2. And but the difficulty with this is we don't actually have this little bit of distance there. So if we want to use that point, it is a little bit awkward to use because we want to use the actual positional angles, the actual x values of the angles. But if you want, you can, and you can figure it out, you can use other symmetries that are involved in here. Okay, so looking at the next one here, this one is in degrees. So we just have to adjust our thinking to degrees. But we have a cosine graph. So again, if we take a close look at this graph, this is a cosine function starting at 1 and going through one period to 360 degrees. There's our cosine function. Now we've drawn more than one period here. So we have the graph that looks like this. So we've been given that cosine theta is equal to 0.5. So I've drawn a line, a horizontal line at 0.5, y equals 0.5. So this is 0.5 here. And we have different positions which give us those angles. So one that's been marked, it's hard to see again because I drew all over this. This point was the one that was originally marked, and it was marked at 300 degrees. Okay, so I've drawn 300 degrees on the x-axis, and the y position is 0.5. And again, we can see that the green ones are related to each other through one period. So if I just trace this out, I can see that if I go through one full circle, I get to the next green point. So if I want to find the position of this green point right there, I can start with my original 300 degrees, and I can find another theta by subtracting 360 degrees, or one full period. And so I get negative 60 degrees is that position. So locating that point there, that is negative 60 degrees. If I want to go backwards to the next one over here, I would subtract another 360 degrees. So I would get negative 420 degrees. So this position here is negative 420 degrees. Okay, so those are our green positions. They relate to theta 1. We also have another position here in red that relates to theta 2. Okay, so this is, I'm going to call that theta 2. And we can see that it's symmetrical about the x-axis here. So if I went left negative 60 to get theta 1, I can go right positive 60 to get the first theta 2. And then looking at going from red to the next red point, that's one full rotation with a period of 360 degrees. So then that next coordinate is going to be plus 360, or 420 degrees. And I can see that I am past the 360, so this location here is at 420 degrees. Okay, and this is 60 degrees here. There's this last position here. So if I start at positive 60 and I go backwards 360, I'm at negative 300 degrees. So that's negative 300 degrees, and I can see the symmetry that's symmetrical to the original green point that I had. I can see that it is the same distance from here to here as it is from here to here. Okay, so that gives me the correct positioning of that last red coordinate. So we want to be able to use symmetries here to be able to find the different points. There is this issue of theta 1, theta 2. All the green coordinates are coterminal angles of each other. The red and green represent a theta 1, theta 2 situation. Okay, they're the two positions for each period that will take on a certain cosine value. Okay, so lastly, what is the difference between the sine graph and the cosine graph? So I've drawn the cosine graph in red and the sine graph in blue. And I can see that if I just take one reference point, from going from the 0 to this point here, so I'm just going to highlight it. If I'm going from this point here to this point here, I've gone forward 1 quadrant, or pi over 2. So really the difference here is a horizontal shift of pi over 2. And in fact, we can make the cosine look like the sine by shifting it to the right. Okay, so if I want to make the cosine look like the sine, I can do cosine of x shifted 1 quadrant to the right, and that would equal the sine. And I could do the same with the sine. I can take the sine, and the sine, though, I'd have to shift it in the opposite direction. So I have to shift it to the left, and that would make it equal to cosine. They're the same shape, they're just different horizontal translations of each other. Okay, so they're different by 1 quadrant, or 90 degrees.